Hello everyone. In this session, we are going to discuss about two important control strategies used in the DC motor drives. One is the time ratio control, another one is current limit control. So these strategies help in achieving the efficient speed control, and we have improved energy utilization and protection of the motor using the operations. So we have a quick recap of this over session, which has the DC chopper fundamentals. So before moving into the control strategies, let us recall the basics of a DC chopper. A chopper which converts the fixed DC into a controlled DC output using the PWM switches, and the duty cycle determines the average output voltage supplied to the motor, and this forms the foundation of modern DC drive system. Next is a quick mind map. So this slide shows the overall concept as a structure. So we have two major methods focusing on this presentation. One is time ratio control, another one is a current limit control. Next one is why this control strategies matter. So the control strategies are necessary for three major reasons. One is the performance characteristics, second one is the energy efficiency, and last one is the protection. So in the motor performance, we can ensure the precious speed and torque control, and in the energy efficiency we can minimize the losses during the operations, and in the protection we can prevent the excessive armature current and overheating. So thus the control improves both the performance as well as the safety. The two primary approaches are, we have two main controls. One is the time ratio control, another one is a current limit control. So the time ratio control adjusting the switching time to regulate the voltages, and the current limit control which ensures the motor current which stays within the safe limit. And next one is the time ratio control. So in this time ratio control, the duty cycle plays a key role in it. So the duty cycle alpha, which ranges from 0 to 1, and by adjusting the on time relative to the total time, we can able to control the output voltages. If you have the higher alpha value, which represents a higher voltage, and the speed is also the higher. If you have the lower alpha value, the speed is also lower and the voltages is also lower. So this method allows the smooth speed control without the power losses. And next is the time ratio control method. We have the two implementation method. One is a constant frequency PWM method. There the switching frequency remains fixed, and the pulse width will varies, and which provides the predictable harmonics and easier filtering. And second one is the variable frequency, which is either on or off time remains fixed, and the switching frequency which varies here, and which is simpler and reduces the switching losses. Next one is the current limit control. So in this current limit control, the focus shift from voltage to the current. So the system continuously monitoring the armature current. The switch turns on when the current falls below the lower limit, and it turns off when the current exceeds the upper limit. So this maintains the safe operating current levels. Next is the current limit controls key characteristics. So this method uses a hysteresis band. So this typical band which varies from 5% to 15% of its rated current. So the wider band which has the lower switching frequency but it has more ripples, and the narrow band which has smoother current but the higher switching frequency will be there. So this switching frequency automatically adjusts with the loads. Okay. Next is by comparing the control strategies. So by comparing the current limit control as well as the time ratio control. So time ratio control, which is a simpler and constant frequencies, we are in need of external current protections, whereas in the current limit control, which provides the better built-in protection and better transient responses, and which has variable switching frequencies, and finally we have the certain points as a key takeaways, and the summary which we are concluding from this overall presentation is that which main for evaluating the uh, time ratio control as well as the current limit control. So this time ratio control adjusts the duty cycle to regulate the voltages, where the PWM is preferred for stable harmonic performance, and the current limit control which regulates the current using the hysteresis band, and it provides the inherent protection. So the choice of this method depends on the application. So if you're going for a general use, we can prefer the time ratio control, and if you go for safety as well as critical system, we can prefer the current limit control. So I hope you have understand the concept of this control strategies. So with some of the interesting topic, we will meet in the next video. Thank you.